So you have, everybody got the sheet in front of them? And let's go ahead. So here's the sheet that we're going to go over. We're going to do first of all, a feeder for all these cooking units and ranges. And the way I like to do it, guys, question number one, I give you guys a sheet. Everybody should have a sheet of the review. For question number one, I personally like to always draw a feeder, guys, and size the stuff. You don't have to do this one for the test, but size we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we have 4 types of loads, right? 4 types of loads, just to give you an idea what we're doing. This is a 5 kW. This one is a 7 kW. 7 kW. And this one is 11 kW. And this one is 16 kW. All of them are fit from a panel. We have a panel that feeds all these boys. Cool. Each one of them, I have 2 of this, and I have 4 of this, and I have 1 of this, and I have 3 of this. Does that make sense? I have a panel that feeds all these equipment. These are cooking unit. This is a cooking unit. This is a range, and this is also a range, and this is a range. Cool? So I have 3 sizes of ranges and 1 size of cooking units. Can I have a thumbs up, Chad? We understand fully what this is. My system is 240/120 volt single phase. Very important to specify the system. And this is my panel that I'm feeding all these equipment from. And you guys being the designers, you're faced with a problem of sizing the branch circuits and the feeders for this panel. Can you have thumbs up, Chad? We know how to do that. So we're going to be sizing the branch circuits and the feeders for this panel. That's basically what we're going to be doing. So let me start by the first thing we're going to size, guys, feeder ungrounded conductor. So I'm going to put the first thing you need to size is A. I'm going to put A here. That's the feeder ungrounded conductor. Also, we're going to be sizing the neutral. I'm just going to show the neutral coming in here by itself, my neutral or grounded conductor. The second thing I would like you guys to size is B, is that neutral here. Oops. Okay, everybody knows what first the phase, second the neutral. This is B. Third, I would like you guys to size the overprotection device. That will be a C. Does that make sense? Where things are located, feeder, overprotection device, then branch circuit for the 7. I just picked the 7. I would like you guys to do the same thing. Branch circuit, grounded conductor and ungrounded conductor. So this will be D, will be the ungrounded conductor for this one. This will be a D. And also the neutral conductor that's coming to D. I picked D, and I would like you guys to size, this is also E. This is E. Cool. And then I went all the way back to, this is the 7. And overprotection device is F. Overprotection device is F. And so this is branch circuit, then branch circuit ungrounded conductor. Then we went to the 16. We picked the 16. We did the same thing. I would like you for the 16 to find G. And this is the conductors. Grounded conductor is basically the neutral. Can you guys see the neutral coming here all the way to here? So I would like you to size the neutral, which is, what's the neutral? It's H. Okay. And the branch circuit overprotection device is I. The branch, this is my I. Okay, so that's basically all the stuff that I would like you guys to size. Now, Jeff is looking at me and said, Chad, well, do you want us to size 11, the same thing, branch circuit for 11 and 5? Up to you. I mean, the only thing I'm asking for are these, sizing these ones. Cool? That's all. I'm not, now in a real life, as a designer, you guys are going to be sizing everything. You get a panel like this, you size everything. But so 5 kW and 11 kW guys exactly the same like 7 kW and 16 kW when we size them. You're gonna see. Can I have thumbs up, Chad? Everybody's okay with that one? Yeah, we need them. We need all this stuff for the main. Well, we're sizing feeders and branch circuits. The feeder is only one feeder. The branch circuit, I only picked 2 branch circuits to size. The other 2, I don't want to size them for this exam. Cool? Can I have thumbs up? Everybody's good with that one? Okay. Now to help us with that, guys, why don't you go to 220.55, table 220.55, and let's go right into that boy, 220.55, because that will be our, let me see, 220.55. And if you go to 220.55, so let's go first of all size the feeder. So I'm gonna go alphabetically through them. So any question about what we need to do for this job? Can I have thumbs up, Chad? We know exactly. Okay, let's go. So this is what we need to do. Let's go do it. So we need to size the feeder. So I'm gonna start with this will be 1A. 1A. Oops. I want to start finding A. 1 and A. Okay, A is the feeder ungrounded conductor. So I want to bring to your attention, guys, the sizes that we have. If you look back at the sizes that we have, just quick, look at the size. 11 and 16 are more than 8 3/4, right? More than 8 3/4. So there's one rule that applies to the 11 and the 16 sizes. There's another rule that applies to the 5 kW and the 7 kW. The 5 kW and the 7 kW, they're under what? They're under B. So the rule B's will apply to them. 11 and 16 are under C, and C will apply to them, and then we add them together. Cool? All right, so let's go ahead and start. Let's take first if the code says, guys, if you have multiple ranges, different sizes, and they are more than 8 3/4 under one of these, not number 2, you have to add them up. Anything less than 12, you have to up it to 12, average them, increase the average by 5%. So let's just start with the 11 kW. 11 kW plus the first thing you need to do is take the 11 kW plus the let me just do it this way. We're going to take 12 here plus 16. 12 times what though? Because there's multiple of them. So I'm going to take the 12 multiplied by how many 12 do I have? 1 plus 16 multiplied by 3. Divide all this by how many ranges in this that we have? 4. And I don't have the answers for this, so I need 2 people to find me the answer. Let me repeat myself. This 11 here, this 12 came from the 11 kW. Anything lower than 12, you make it 12. This rule is from table 220.55. 50. Oops, I hate it when it does that to me. 220. 16 times 3, and this is coming from 220.55. Note number, which one? Note number 2. Note number 2. Okay, so you guys go there. It says you have to average them. Okay, anybody can? 2 people give me the answer.
15 kW. 15.
Even? 15. Okay, so I have 15 kW. 15 kW. Okay? 15 kW. That's the average. Okay, so that's the average for these two. Did you guys multiply 12 by 1 plus 16 times 3, divide all by 4? Right? 15. Everybody's good with that? Okay. Okay, good. Then how many ranges of this I have? I have 4 ranges. 4 ranges under Go to column C, under C, 220.55 table. What do you guys get for 4 ranges under C?
17.
Thank you. You get 17 kW. Okay, 17 kW. For 4 ranges under C, why 4 ranges? Because I have 112, 111, and 316. That will be give me 4. Okay, now note number 2, guys, says you have to increase the 17 5% for every kW. For every kW, the average is more than 12. So let's do that. So this is your step 2. Step 3, you're going to take the 15 that you did, subtract 12 from them. That will get you 3 kW. 3 kW translate to 3 times 5%. That will get you, what's the increase? 15% increase. That gets you the 15% increase. The last step that you need to do is to take your 17 kW and increase it by 15%, which is 1.15, and you're up. Can I have 2 gentlemen agree on that?
For step 3, why was it 5 times?
Go ahead.
Why was it 15 kilowatts for step 3? 15 minus 12, would it be 17 minus 12? So
No, the average. If you note number 2 says you take 5% for every 1 kW, the average is more than 12. Not column C. The average is more than 12. Right? This is the average. This is average. Finding the average. Right? Any question, guys? So can somebody give me the answer for this?
19.55.
19.6 kW. Anybody get? So that's basically the demand for the feeder. That's the demand for these two. For those, yes. One significant digit is good enough. Yep. Cool. Yes, sir.
I'm sorry, so it's locked in, but on the first step you put 12 and 16, and it's 11. So why does it become 12?
Because note number 2 tells you so.
Okay.
If you read note number 2, it says anything less than 11, make it 12. Anything less than 12, make it 12.
Okay.
Does it make sense?
Yep.
Yeah. So that's please, guys, highlight these. The test tomorrow is going to be very similar to this. Cool. All right. So now this is for the first ranges. How about let's look at the other 2. The other 2, guys. How many of them do I have? I have 2 5 kW and 4 k and 4 7 kWs, right? So this is the one. This is the first. Make sure you highlight this one. This is just from this step. Then I have another bunch of under. So let's just say now I'm gonna flip though. So I have 2 5 kW and also 4 7 kW. Now both of for 7. 2 5 kW and 4 7 kW. 4 7 kW. Okay, both these are under which column? This is under B, column B. Okay, so column B, how many of these do I have? I have 4 plus 2 is 6. 6 ranges under B. 220.55 under B. What's the percentage that you have? Right? Anybody disagree? Well, I have how many of them? 2 plus 4 is 6. 6. That will give me under B 43. Okay? So 43% as your multiplier. Then what the code says, guys, you add them up. It becomes, so that's step 2. Step 3, you find the, step 3 is you find the 2 times 5 plus 4 times 7. Anybody can give me the answer for this? 10 plus 38. 38 kW. And the last step is to cut them by 0.43 because of the derating. 38. I need two gentlemen to agree on one answer. How much? 0.43 times 38.
16.3.
16, second? 16.3. 16.3. I'm going to highlight this, and I'm going to put another also circle in it. Okay? So there are two sets of ranges. One set goes under column C, and the other two go under column B of 220.55. We apply the rule of C to the C ranges and the rule of B to the B ranges. Can I have thumbs up, Chad? We know how to do that. And then, what do you do at the end? Add them up. See how easy that is? The last step, guys, going to do is add them up. Before I switch to a different screen, can I get when you guys are done, give me thumbs up. So, Andrew, on our test tomorrow, you're going to see very similar problem with different sizes. Here's the confusion is, make sure you understand the notes, because if I change it tomorrow from 5 into 3, that will put this one where? Under A. And you have to go apply the A just to these two. Okay? Any question guys about this?
We do the same thing for A.
Yep. Percentage. All right, so let me know when you guys are done with this. I want to remind you this will be PDF too. This will be PDF. Okay, that's it. This is really the hardest part, is just to go through all this mess, and then the rest of them is piece of cake. So can I have thumbs up when everybody's done? Done, done, done. Okay. Andrew, can I move or no? Go ahead. All right. Now the last step, guys. We're still in question number 1A. The last step was, can you give me the two sizes that I want to add them up, the last step?
19.6.
19.6 kW plus
16.3.
16.3 kW. And I need two gentlemen to give me the total.
35.9.
35.9 second, 35.9 kW. This is the ultimate demand. This is your demand now for the whole system. All of these ranges and cooking units will be seen as on the system as 35.9 kW. That's the number they're going to use to size the feeder and the overconduction device and all this mess. Can I have thumbs up, Chad? We understand how to go there? All right. Now, after we do all this mess, now let's go find A. Now we need to find A, guys. I need to find the current. The current equal, I need to have the 35.9 divided by, what's the voltage system? 240. I need two people to give me the amps.
150.
150. Second? Okay. Even?
149 point something.
149 point, let's just do that. What's the something? 0.6, awesome. 6. Let's just put it this way, M. Okay, that's piece of cake. So what is A anyway? A is ungrounded conductor. So now I need to go take the 149.6 M. You need to take it to 310.15 B16 under which column and why? Column 60 or column 75 degree? Why 75? Thank you, sir. 75 degree. 75 degree column. I need a gentleman to give me how many conductors first? How many conductors do I need? This is single phase. How many ungrounded conductors in single phase? 2. So I need 2 conductors. And what's the size? 1 aught. I need 2 gentlemen to agree on the answer. 1 aught. Wow, was I even? 1 aught. So 1 aught A W G T H H and conductor. I decided to use THH. That's it. That's what designers do. You have to specify the number of the conductors and the size and the insulation. Does that make sense, Joe? Is that what you guys do? The number of the conductors, the size, and the insulation. Why THHN? Because THHN is 99% of the time, if you're indoor, you're using THHN. It's dry location, right? Okay. Now, did I say what wiring am I using here? I didn't say ranges. Okay. Now, if I told you if I told you guys we're using an cable, then where do you go? 60-degree column. No question asked. We didn't say an cable. We're using conduits and wires here. So, all right. Okay, so what's B? B is feeder grounded conductor size. Feeder grounded conductor size. Let's go to B. B is the grounded conductor, the neutral. The neutral. So here's how you start, guys. You take the I, 149.6 amps. And if you guys go to, where is it, 220? If you go to table 220.61, to article or section, 61, permitted reduction, service, 3-wire, where is it? Is it A or B? Prohibited reduction, no, permitted reduction. You're going to go to B, item B. It will tell you if you have ranges, you can cut them by 75%. The service or feeder supplying the load shall be permitted to have an additional cut of 70%. A feeder service for a range. Everybody can see that one, B 220.61 B1. If you guys can go there, B1 in particular, it will tell you that you can cut by 70% for feeders and service. Now, where's Adam? Adam, does it say anything about branch circuits? So this is very important for what's coming. Does it say anything about branch circuits? No, feeders and services. So this is what we're doing is a feeder. So, okay, so what does that mean? You take that big boy, 149.6, multiplied by what? 0.7. I need two gentlemen to agree on an answer. 104.7 amp. All right, so same situation that we did. You're going to take the 104.7 amp, you're going to take it to where? Excuse me. 310.15 B16, the table under 75-degree column, and that will give you one conductor for the neutral. Number one. Number two. Thank you. Number two, A, W, G, T, H, H, N, done. Does that make sense, guys? Why did I multiply by 0.7? Because this 220.61 B1 says for ranges, feeders, and services, go ahead and chop that boy by 70%. Any question? So here's A and B. Then we hit C, as long as on it, C is very easy. And then we flip into C. I'm going to put C right here just because it's easier. C. Here's my C. C is overcurrent protection device. For overcurrent protection device, very easy. You take the amps that you got. Where's my amps? 149.6. Take this one always to 240.6, section 240.6. And the next standard overcurrent protection device is what? 150. That's it. So what's the overcurrent? C, if you guys read what C says, C need an overcurrent protection device, a circuit breaker. So how many circuit breakers do I need? One circuit breaker, three. How many poles you need? 2 poles. So this will be, technically, you're going to see 150 2-pole circuit breaker, right? 150 amp 2-pole circuit breaker, done. If you decided to use fuses, 150 2 fuses instead of 2 poles, with a disconnect of 2-pole disconnect with them. So that's, we size the feeders. We size the feeder, overcurrent protection device, the ungrounded conductor, and then the neutral. So that will be A through C. Any question, guys, about A through C? Yes, sir?
What if there's two on A, two conductors on the top on A?
2 because of my system is 24120. 24120 has 2 hots for the 240 and 1 neutral for the 120. Yeah. If we're using a 28120, then you're using 3. So we're using single phase, 3 hots. It becomes 3 hots because 3 phase. 24120 is always 2 hots, always, and 1 neutral. 24120. Yes, sir.
Why do we use the 75-degree column?
Because over 100, where's the amps? My amps are over 100 here, and my amps are here. My amps are over 100. When your amps are over 100, you always default to 75. Unless they tell you otherwise. Did they tell you anything about logs and anything? Now tomorrow, guys, on the test, you're going to go by the amps. If your amps here was 99, what am I going to do? You're going to go directly to 60-degree column. They have thumbs up. We understand that. Remember when we went through the whole cutoff, that 100 and less, it's going to be following you guys from now until you graduate with check. So, unless they tell you otherwise. And how do I tell you? I would say all terminals are rated for 75, then everything is 75. Okay? Let's go again. Can I move it to the next one? Next one. Okay, the next one, guys, is the branch circuits. So we size the feeders, as you can see, right here. We size the feeders, which is A, B, and C. Now I need to go size at one branch circuit, A, B, C, D, E, and F. I'm going to go size the branch circuit, one branch circuit, and then a second branch circuit. Everybody knows that we're moving to a branch circuits now. We're moving to branch circuits. Okay, so this would be question number 1. Still question number 1. So I want to go to A, B, C, D. We're in D now. Okay, so D, what was D first? D is a branch circuit for a range, 7 kW range. It's 7 kW range. Okay? Now for ranges, the code allow you to size them based on the table, based on this table. You know, so if you go to if you look at the branch circuits load, the branch circuits for it shall be permissible to calculate the branch circuit load for one range in accordance with table 220.55. One range in according to 220.55 permissible to one range. Since it's one range, is it a range? Yeah. So can I use the table because of note number 4? So I'm going to say right here, just note number 4. Make sure you know note number 4. For note number 4, I have one range. So you take your range 7, take it to the table 220.55. Under this one is under B, right? Under column B. What's your demand? 80%. So I have an 80% demand. Then you take the 7, multiply it by 0.8. What do you get? You get 0.8 over 7. 5.6 kW. Then you take the 5.6 kW divided by 240 to find the amp. What do you get? 5.6 kW divided by 4, 2040, anybody? 23.3 amp. Okay, cool. All right, so that's basically the size I'm going to be using based on the permission because it's a range. Now let me tell you one other thing. If it was a cooking unit, you would not do that. You would use the 7 kW. Okay. Now the rest is history. D is the feeder. So I need to go to 23.3. You're going to take it to table 310.15 B16. Under which column and why? 60-degree column. Why? Less than 100. What do you guys get? Number 10. And how many conductors? 2 conductors. Number 10. A, W, G, T, H, H, N. Done. Does that make sense? That's piece of cake, D. The grounded conductor, here's the tricky one. Now the second, this is D. E, guys, is a grounded conductor. The grounded conductor, Jeff, for a branch circuit, do we derate it? No, we don't derate for branch circuit. So it's the same number. So, right, because it's branch circuit, the conductor, no duration, the conductor is also 110 A W G T H H N. No derating. Can I write no derating for branch circuits? No derating. No derating for branch circuits. No derating for branch circuits. Can I have thumbs up, Chad? We know. So you're going to end up with basically 3 conductors. The last thing, A, B, C, D, E, F. F. Look how easy F is. So F, guys, the same thing. You're going to take the 23.3. Where do you guys want to take this one? To 40.6. What's the next overconduction device? 25. 25 amp. 25 amp. Now, because 25 it's not commonly carried, what do we typically do? If you answer it on the test 25, I'm done. I don't need you to do anything else. Typically, guys, we go to 30 amps because it's the next commercially carried overconduction device. And does 30 go with number 10 based on the small conductor rule? Yep, then we're good. So tomorrow for the test, size strictly based on 240.6.
Okay.
Okay?
So if you did give the 30 amp, would you count that wrong?
No, absolutely no. Absolutely no. But moving forward, I want you to, here's what I would like you to answer. You go 25, but typically because 25 is not commercially carried, we go to 30, but we check back, does number 10 is allowed to be protected by 30? Yes, done. If you put 25, you're good. If you went to the extra step and you said we're going to go up it to 30 because number 10 can handle 30, it's also good. Can I have thumbs up? We got that one. Okay, see how easy that is when you start the branch circuits? Aaron, does it make sense? More or less? Digest it. Really, the steps. Okay, can I go to the next? F, we're going to do the same thing for G, H, and I, right? G, H, and I. Okay. We're still in, did it go too fast? So question number 1. Are we in G? G. Now G, guys, just to remind you, G was, what's the size of the branch circuit? It's a 16 kW. There is a 16 kW board. Now for 16 kW, it's a range. It's a range. So do you guys remember what the code says about ranges? You can use the table for branch circuits exception. So table 220.55 under which column? C. Under column C. What's the demand for that boy? What's the demand for one of them? Now how many of them do we? I need only one of them for the branch circuit. There's only one of them. So what's the demand? Is it 8? Yep. 8. Okay. There's an 8 kW. There's one little problem though. Is it more than 12? Yep. So you're going to up the 8, 5 kW for every 5% for every kW more than 12. So you go one range because we're doing branch circuits. One range, 8. Then 16 minus 12 is what? 4 kW. The next step would be 4 multiplied by 5%. That will give you what? 20%. And where did I get these? Where did I get this? From note number 2. From the table 220.55, note number 2, if you don't believe Chad. Why 16? Because the size is 16. Why 12? Because note number 2 says if it's higher than 12, you have to, actually in this case, not number 1, because they're all the same size, aren't they? Not number 1. Not number 1. Oops. Not number 1, right? Because I only have one, and it's the same size. Okay? All right, piece of cake. Then the demand for that beast is what? You take the 8 kW and you multiply it by 1.2. Why did I multiply by 1? Because the table gave me the 8. Why did I multiply by the 0.2? Because that's the up. You're up at 20%. I need 2 gentlemen to agree on one answer. 9.6. 9.6 kW. Okay, now this is where you start sizing. Then you take the 9.6. You need to find the amp divided by 240. How much? Even? Okay, good. 40 amp. Another second. Do we have a second?
40.
40 second. Okay. Here's my amp. All right. So now G, what was it? The conductor. G was the conductor, right? So now it's piece of cake. 40. Take it to table 2, 310.15 B16 under 60-degree column. What's the conductor they can go? 2 conductors number? Number 8. A, W, G, T, H, H, N. Oops. So done. Here's my conductor size. As long as I'm on it, G, I'm going to do H because it's the same, right? H, see how it's H is going to be? H is for the neutral, right? Neutral. H is for the neutral. So the same size, right? Everybody knows it's the same size. H is for the neutral, so I use 40 amp. Same table. 2, 3, 10.15 B16, 60-degree column. That will end up with 1 conductor. Number 8, A, W, G, T, H, H, N. So how many conductors do I need? 3 conductors. All of them are number 8. Why didn't I derate the 40 amps, Jeff? Because the neutral for branch circuit is not deratable. Can I have thumbs up, guys? Good. The last thing, so this is H. The last thing is very easy, is I. I is overcaptation device. That's piece of cake. Here's my I. Overcurrent protection device. So the way we do it is we take the 40. Where do you guys take the 40 amps? Same way. 240.6. What's the next step? Is 40 a standard? We hit the jackpot here. So 40. By the way, if it wasn't the standard, do you go up or down? We go up. That's it. We size 2 branch circuits and 1 feeder. Now, if I ask you guys to size the other 2 branch circuits, would it be hard? Same way. Same way. Okay. Shall I roll into the second one, or do you guys want a quick break? Do you want a quick break, or shall I roll in the second one? Roll. So if you guys look here, here's what we basically sized. We size all these A through I. The feeder, 1 feeder and 2 branch circuits. 1 feeder, 2 branch circuits. Now, Kerry, my friend, if I ask you to size the branch circuit for the KW and the range, here's the hint for tomorrow. If I ask you for the cooking unit, would you apply the table for a cooking unit? No. If I ask you, where would you apply the table? Branch circuit, just the branch circuit sizing. You apply for ranges only. Cooking unit right to 70 is not, you have to, so if I want to find the branch circuit here, what would you do? You take the 5 kW divided by 240 and do the same thing. If you apply for 7 and 11, like for 11, you go to the table, the rate, and then you apply. That makes sense. Okay, so that's as ugly as it gets. Let's have, why don't we have 5 minutes break, guys, and then we'll jump into the second one. Second one not as involved in these. This one is the most involved one.
Say that note again about the cooking unit.
I'm sorry, say again.
You say that note again about the cooking unit.
Cooking units, when you size the branch circuit for cooking units, you do not use the table. You just use an nameplate. For ranges, you are allowed to use the table for branch circuits as well as for feeders. Okay.
You probably won't ask us to do a branch circuit for a cooking unit.
I'm basically using this box to house these 6 cables. I have 14.2, the blue 2 14.2, and I have 2 12.2, and I have 2 10.2, right? So what's my job? You guys have that little sheet in front of you. My job is to do 2 things. Number 1 is find the minimum size square box that I need for this system. Size the square box. That's problem 1. Problem 2, after I find the minimum size, I need to check if I can throw another 14.2 in the box after I find the minimum size. Any questions, guys, about what's given? This is right in the front of you here, the sheet. You guys looking at the sheet in front of you too. Okay. I want to remind you, there are no devices in this box. The only thing is clamps. There are clamps. And these are all cables, 14.2, 10.2, and 12.2. With the cable, Aaron, every cable has what? An equivalent grounded conductor. Don't forget that one. So this is basically box fill problem. So what I would like you guys to remember is you need to go to a couple of tables we're going to be looking at in a second here. But this is 314.16b. To find all this information, 314.16b. That's where all the info that we're going to be looking at, article or section 314.16b. 314.16b, box fill calculation. Okay, so let's go ahead and do it. So what do we need to do? Number 1, A, I need to find minimum square box. So let's go to A. Minimum square box, right? The minimum size of the square box, as you guys have it in front of you. First I need to take all the conductors. So let's start with biggest to smallest. So I have 2 conductors, 10.2. So how many conductors would that be? I have 2 conductors. Each one of them is 10, right? 2 conductors, each one of them is 10. What's the allowance for 10? The allowance for 10 is 2.5 multiplied by 2.5. Now, for those of you who forgot where 2.5 came to be, this is from table 314.16b. 16b, the table. Oops, does that look like a B? There you go. B. Can I get a thumbs up that we know where the 2.5 came to be? How about the 2? Where does the 2 came to be? Because there are 2 of them, right? And there's another 2. Where's the other 2 came to be? There are 2 cables. Right? There are 2. The first 2 for the 2 cables. The second 2 for the 2 conductors in each cable. And the 2.5 is coming from the table. Can I have thumbs up? There are 2 cables. So each cable have 2. So how many conductors all of them have? 4. Can I emphasize the first 2 for the cable, the second 2 for the conductor inside the cable, and the last number is coming from the table, cubic inches allowances. Piece of cake, Chad. Before I move on, can everybody, because that's how all of them are going to be. Can I have thumbs up, Chad? We understand where the 2.5 came to be. All right. So that's for the 2. Let's do the other 2. 2, number 12, 2. That's piece of cake, Chad. The first 2 for the cable, the second 2 for the conductors, and for number 12 from the same table, it's 2.25. 2.25. So where does the 2.25 come to be? From the same table, which is 314.16b. Piece of cake, Chad. Let's do the second one. 2, number 14 this time. 14, 2. Same thing, 2 for the cable and 2 for the conductor. And what is it, 2? And 2.0, right? Is that 2.0? Yeah, 2.0 for the conductors. Now here's what happened tomorrow. Zach, you're laughing. I'm going to change it into from 12.2 into 12 what? 3. Right? So if you just copy in 2 to 2 here, it's not going to work for you because Chad's going to go screw it up, make it 14.3.
Not very nice.
Not nice, huh? All right. Okay, so I have all the cables. What else am I missing? These are for cables. I'm going to tie here. All these are cables. Thank you. The last thing is, so these are all, the second one is equipment grounded conductor. Equipment grounded conductor, you size it based on the largest of the whole system. What's the largest in the system? Number 10. Based on number 10, you have to only one. You size it based on one conductor in one cable. One conductor and one cable. So, and that will be number 10, that will be what? 2.5. Everybody knows why. One, the equipment grounded EGC, equipment grounded conductor, you take the largest, fattest, fluffiest conductor, you size it based on it, one conductor in one cable. So you don't have to worry about everything else. Cool?
We don't have any devices on this. This question's too easy.
I know. So we can add a device for you to make it complicated.
You can say something like that. You get Jeff on that. I'm gonna get my ass in the parking lot.
All right, equipment grounded conductor. Just calm down here. Clamps. Clamps. All the clamps, can you guys see these black little things? Internal clamps. All of them count as one based on the fattest, fluffiest conductor. So all of them count as one based on the fattest, fluffiest conductor is what? 2.5. This is based on what? Based on number 10. You base them on number 10. I'm just putting the base, based on number 10. Okay, that's a piece of cake. Now I need a gentleman to add them all up and 2 people to agree on the answer before I adopt it, because I don't have the answers for them.
32.
Now, before I go here, Zach, everybody knows that we're multiplying and adding all of them up, right? We're just plussing them up at the end. Okay, what was that again? 32. Second? 32. Thank you. 32. 32 cubic inch. So my answer is 32 cubic inch. 32 cubic inch. Okay? Now, I'm asking you guys, now the question is, find me a square box. I need a square box, the minimum square box. So what the question is actually minimum square box. What's the minimum square box from table 314.16a? You have to go to a square box. You can't go to anywhere else.
4, 11, 16, like 2.5.
Which one would that give me 32?
42.
That will give me 42 because I have 20, 30. Yeah, so basically the largest, the largest one that I can get, which is 42. The largest one that I can get. Does everybody knows how to use this table? You're going to go to the square boxes and 314.16a, which I guess walk you through that one if you remember. I don't want to flash it. When you guys go there, you're going to find a number that 32 or higher, right, Jeff? So I have 30. The regular square boxes are not, they don't have enough juice. You have to have a wide one. So my size will be the largest, which is 4 by 11/16. 4 and 11/16 by what? 2 and 1/8. 2 and 1/8. This is my square box. So it's 4 and 11/16 by 2 and 1/8. Can I have thumbs up, Chad? We know completely how we came up with this box. That's the largest box we can get for this system. Now Zach is laughing about because there's no devices. Now take this one from NM and put it MC right above the ceiling here. That's exactly what we do. For commercial, exactly what we do. Would it matter if this, I'm using an NM cable, if this is an MC cable, would it change the calculation? No. So that's why we use the J-box. We don't use J-boxes in dwelling, guys, but we use them all the time in commercial. So that's how you size a commercial J-box, right at the top, so you can move to different locations. Carry, my friend, thumbs up, cool. Okay, the last thing, guys, is I need, now, I size the box. Question B is asking me, it said, how many cables, remember, how many cables, 14.2 I can bring to the box, extra 14.2 I can bring to the box. Okay, so I'm gonna go to 2. This will be question number 2B. Okay, what was, can you give me the box, what was it again? 4 and 11, 16 by 2 and 1/8. Now I have a box, I already have the box. I need to know how many extra 14.2 I can add to the box, cables, not conductors. So basically every conductors you have to have two cables in it. Every cable have to have 2 conductors in it, 14.2. So the way we handle this, the first thing, guys, is we take how much room we have in this. So take this one, and how much room do you have in this one from table 3, 14.16a. How much room? 42?
Yeah.
42 cubic inches. That's the first thing you need to do. First we size the box. Now we'll go back and see how much room actually the box has. Okay, 42. And we used how many of this? 32. So this is the box capacity. Then right underneath it, used cubic inch. How many cubic inches are used already? 32 cubic inch. Extra cubic inch. How many extra cubic inch we have? 42 minus 32, give me what? 10 cubic inch. Okay? Right? That's easy. This is how the box can handle. This is what we already occupied from the box. That's the leftover, 10. Now we're asking about cables. So the last thing is 14. I need to know how many 14.2 I can put in this box. So then you take the 10, divide it by first 2 because there's 2 conductors in every cable, right? Why did I multiply by 2? Because there are 2 conductors in this cable. And second, what's the allowance for the 2? 2. So you're going to divide it by 4, basically. One more time. What was the first 2? The first 2 here is for the cable. Conductors in the cable. Right? There's 2 conductors, 14.2. Guys, when you have a J-box, you don't bring a conductor to a J-box. You bring a cable. You can't bring a conductor. You have to put a conductor either in a cable or in a conduit. You can't just bring a conductor if you're using cables. You have to put it in a conduit. Okay, what's the second 2 come from? This 2 is from 314.16b, right? The allowance. Okay, so that's piece of cake, Chad. So let's do it here. 10 divided by 4 is what? 2.5. Now, can you have a 2.5 of a cable? Oops. We can't have 2.5. So this is, you're going to go, then you're going to take the 2.5 and go down to how many conductors? So I can install 2 cables of number 14.2. Thank you. 2 cables of number 14.2. Everybody knows why I went down to 2.4. You can't have 2.4 cables. We're talking about cables here. You can't have a half of a cable. We go down, yeah. Can you have half of a cable? Yeah. And you need to, why did I go down? Good point. Because if I went up, I will exceed the allowances. I have only 10. I will exceed the 10, and that's violation. Can I have thumbs up, Chad? This is piece of cake. We know how to do that. Now, if your feelings are hurt, we can throw another receptacle in it. Yes, sir.
Well, I said, because I just want to make sure I have this right. When you do have, like, the Untitled yoke or strap, is it...
Can you guys hold your horses? I can't hear.
Is it 2 times the...
Yeah, 2 times the allowance for the conductor that land on the device.
Okay, so if I had like a switch on there, then it would be 2 times whatever the largest conductor coming into the box.
No, landing on the switch.
Okay, so if there was like a 10-2 and a 14-2 coming into this box, then whichever one was attached
You'd have to
to
specify
the
what.
device.
Which one is landing on the switch and which one? Yeah. When you have the allowance for the devices, it goes by the conductor that terminated on that particular device. So if the conductor terminated on the switch is number 10, it goes allowance of 10, 12, 12, 13. No, there's no 13. 12, 12, and 10, 14, 14. Okay. Can I jump to the next one without hurting anybody's feeling? Can I? Yes? Cool? Okay. So let's go, guys, to the second one. Question number 4. Question number 3. Here's what question number 3 is. Question number 3 is what you would never do. Can I have thumbs up, guys? And I'm telling you that question number 3 is the thing that you would never do. So let's go back to all our. There you go. So if you look at question number 3, we did this. Now we're question number 3. Question number 3, I have a you would never do that as an engineer or designer. You wouldn't group feeders and conductors in one conduit, especially when there's the rating. Bad idea, just to give you an idea. So we have a conduit. If you guys look at EMP conduit, and I have 2 conduit houses, 2 number 10 AWG and 3 number 4, and I have also 4 number 2 watt. That's it, right? All in one conduit. And I have a temperature of 40. Can you guys see the temperature of 40? So I have to do it based on temperature. And all of them are carrying conductors. So I'm going to highlight these for you. Here's this one here, and this one here, and this one here. And all of them are carrying.
14 is not part of it.
Oh, this 4. Oh, I'm looking at the top here. Start to see this one and this one, right? These are 3 sets of different size of conductor coming in the same conduit. They're all carrying current, their phases, and I need to do it. So let's go do that. Can I have thumbs up? We understand what the issue is. So let's go do that. All right. Okay. So here's what I like to do before because I'm a graphically oriented individual. I don't know if that's true or not. Here's your conduit. So the first, let's go ahead and start from bigger to smaller. I have 4 conductors. Number 2 is 1, 2, 3, 4. Each one of these has 2 at T H H N. Okay. These conductors. The second set of conductors, guys, is I have another 3. 1, 2, 3. These set of conductors are number what is it? Number 4. Number 4 T H H N. That's not enough for you. I also installed number 4, another set of number 2 conductors, number 10. So here's another conductor, 1 and 2. These 2 conductors are number 10 T H H. How many H's did I write here? T H H N. Can you guys see it? All of these are in one big fat conduit. To add salt to injury, we're putting him in an ambient temperature of 40 degrees Celsius. We're putting him in an ambient temperature of 40 degrees Celsius. Can you have thumbs up, Chad? We understand fully what's going on here. That's what you wouldn't do. You wouldn't do that in a good design. Cool? Can I have thumbs up? We understand what's fully engaged in that boy. And also what's needed. I need to find how much current each one of these conductors can carry. And I'm only interested, as a matter of fact, not in all of them, in only number 10 and number 2 watt. I'm interested, if you group them all like these, how much current number 10 can carry, and also how much current number 2 by itself can carry. And what's the overcome protection device you're going to put at the head of it? I need the thumbs up that we understand what the problem is first. Cool. Let's go do the solution. A. So A for this one, maximum current that one conductor, I have one conductor, number 10, how much THHN, the maximum current that one conductor, number 10 can carry. Okay, that's piece of cake, Chad. since it's THH and what do you guys do and we're derating, you're going to go to 310.15 B16 under which column and why?
90 degrees for derating.
Thank you, 90 degrees. So how much current number 10 can carry under a 90-degree column? One of them.
40.
Thank you, sir. Any second?
40.
Okay. Did you look? I got you this time, huh? All right, 40 amps. Okay, now this is not for sizing, for derating only. Okay, that's a piece of cake, Chad. We can handle that. The second step, guys, you take your 40. Number one, you need to derate the 40 based on how many carrying conductors do we have. I want you guys to count all of them. We have 4 2-aught, 3 number 4, and 2 number 10. How many carrying conductors do I have? 9. So I have 9 carrying conductor, right? Everybody knows they're different sizes, but they're all carrying current. I have to tell you that, guys, and they're all phases. We're shooting phases. Kerry, does it make sense? Yes. Where did they get the 40 amp? Under 90-degree column? Okay. Now do me a favor. What's the derating factor for 9 conductors? From which table? 310, where am I here, Chad? Okay, thank you. So I'm going to go, what's the derating factor for 9 conductors? 9 conductors is 70%, right? Everybody can see that? So I have to multiply here by 0.7. And where did the 0.7 came to be? This 0.7 is coming from 310 table, 310.15 B 3A. B3A. Okay? Then you multiply again by another number. So this, everybody knows where the 70% came to be from 310.15 B3A based on 9 carrying conductors. Now we put it right in the middle of Arizona in the desert. 40 degrees Celsius is very hot. So I need to find the derating factor based on the temperature too and multiply it. For this one, guys, you need to go to table 310.15 B2A. Okay, B2A. Can anybody tell me, guys, under 90 degrees for 40 degrees Celsius? Look at the Celsius. What's the derating factor? I need 2 gentlemen to agree on a number. 0.91 under 40 degrees Celsius, not Fahrenheit, and 310.15, 0.91 second. Any second? Second. So this will be 0.91. And where the heck did you get this one, Chad? This is from 310 table 310.15 B3 or 2 B2A. I'm sorry, B2A. There you go. B2A. And I want to remind you guys that I walked you through these tables before, so I hope you register them. If you need help how to use these tables, please let me know. That's why I don't flash the tables anymore. I assume you guys will walk you through it and you just can jump in. Okay. Does that make sense when we got these numbers? Now, who's going to be my favorite student and give me the answer? How much? 25.48, 25.5 amps. I need a second on 25.5 amps. Second? Second. Okay. That's it. So that's how much current it's going to carry. That's how much current that boy is going to carry. Okay? This is A. Let's look at B. What does B? B says, okay, now, Chad, now that you derated this, look what that B says. Now you derate. I want you, what's the largest overcurrent protection device you can put on this conductor? Now, B is overcurrent protection device. Now, here's what B is. I have the conductor here. This is number 10. And I found that number 10 can only, look at the current that can carry, 25.5 amps. I can't put more than 25.5 amps on number 10 based on the derating. Now they're asking me, based on this situation, what's the largest overcurrent protection device you have to put there? You can't exceed, I want to remind you, You want to limit the load to 25.5. So you want to limit it to 25.5. So here's where you go take then you need to take the 25.5 amp, take it to 240.6. This time, instead of going up, where do you go? Down, because you will cut the void down. You go down if it's not a standard. What's the next standard down from 25.5? Not up. 25. So 25 amp. We're still not too bad though. Look at it. I mean, they just don't want you to put a 30 on it. Does that make sense? Because if you put 30, then your conductors are going to be, they can be, they will be hot. So what happens if I need 30? What do? You size the wire up. Can I get you guys to understand that little derating factor here? Down. So you go stick a 25 amp circuit breaker right to the top of it. Can I have thumbs up, Chad? We know what we did. Why did we put 25? Why didn't we go to 30? Because if you go to 30, then you'll have more amps here. It's going to get hot. So you have to limit the amps to this amount of amps or less. Well, if you didn't get this one, you're going to get the second one because they're all also almost the same. Let's look at the second one. Question number 3. Question number 3. This is now A, B. Let's do C. C. The same thing, guys. The conductor that we have for C this time is 2 aught, right? I have a 2 aught. Number 2 aught. One of these 2 aughts, THHN. How much current this boy can carry? 310.15 B16 under 90-degree column. I'm just repeating exactly what I did in A and B. Really, repeating it. How much number 2 aught? 195. Thank you, sir. It's 195 amps. Okay, for the rating. All right. Next, we have 9 carrying conductors. So we have to have the 195 and cut it by, for 9 of them, still the same, 0.7. Still the same, 0.7, because the number of conductors didn't change for the problem, right? We're still the same problem. Multiply this by the derating factor under for the 40 degrees Celsius. 0.91 didn't change. So 0.91. So you see how it's really easy on the test? It's you just basically doing it again. Doing for a different conductor. Okay, any idea? 124.2 amps. Any second? 124.2 amps. Second, cool. All right, so now, and I can't emphasize, everybody knows where these 2 numbers came to be. If you forgot where they came to be, please go to just the slide before. You see where they came from 310.15B3A and 310.15B2A. These 2 numbers. Okay, then what's next? Now we take 124.2. Oh, this is how much current you're gonna carry. That's it. That's the current that you need to carry. You can't go more than that. So let's go to A, B, C, D. Right? So what does D say? D said, okay, now for this boy, overcurrent protection device, size overcurrent protection device. So here's my beautiful 2 aught. Here's the cab on the load. What's the cab? 124.2 amps. I can't go higher than that, otherwise I'm going to burn that boy. Okay? I'm going to burn it. So what's the next? So we're going to take 124.2. Take this one to 240.6. What's the next standard down? Because we're going to limit that boy. 110. There's 110 amps. 110 amps. So my overcurrent protection device here, 110 amps. I'm limited to 110 amps.
Which column in 310.15 B2?
Which column? 90.
Right.
90 degree, the same column.
This is gonna help me. Okay. I was looking at B2.
Now, just for your idea, just to give you an idea, one little thing to give you an idea. If there is no derating, whatsoever, no temperature derating, no nothing, no derating, you take the 2 out and you go to table 310.15 B16 under 75 degree column. Why 75? Because 3 out is more than 1. How much current that boy under 75 can carry? 175? Can you guys see that? If there is no derating whatsoever, this has nothing to do with the problem, but no derating, just to give you an idea. I'm not derating at all, right? No temperature, no bundling. 2 watt can give you 175. Just to give you an idea, then here's an overconduction device. Then you load, you can put 175 amp load here, and you put 175 amp circuit breaker here on the conductor of 2 watt. Can you see the difference? Everybody can see the difference? We limited from 175 down to 110, and we limited the load from 175 down to what? 124. Disclaimer, 175 non-continuous. If it's continuous, all what you have to do is just cut the load by 0.8% of this value. Do you guys see what happened when you derate as designer? It's a disaster. We went from 110 circuit breaker and a load 175 to 124. We lost a lot of amps. Who cares? You're putting a lot of copper and you're not getting juice out of it. So that's why we try to avoid, guys, bundling, especially in this case. Avoid bundling for feeders. The rule when we design a feeder, especially if you have a feeder, you shoot it in its own standalone conduit. Done. Okay, so this has nothing to do with it, as I said. This is just to give you an idea why we did what we did. And you're going to hear Chad talk about this as we move on with the commercial. Okay, any question about the derating before we go to the last one, which is much easier than anything that you've ever seen? Last question. Last question, very easy, piece of cake. Now the last question, guys. Okay, the last question is this boy. Here's what happened. I have a main 400 amp, and I have a sub panel and another sub panel and another sub panel, 3 sub panels. All of them are 240. They're single phase and they're feeding dwelling. Very important to understand what I'm doing here. They're all dwelling feeding 240, 120, and I need you just to size the overconduction device. To size, in this case, the feeder. I want to size the feeder for each one of these panels. So find the feeder. Okay? Everybody can see that? Everybody has that? Okay, so let's go and size the feeder. Let me draw that one a little bit so I'll give you an idea what we're doing here. Okay, so let's go to 4. This is question number 4. Question number 4. Here's a main panel. That's exactly what you guys are doing for your friend Chad. Exactly what you're doing for your friend Chad. 3 panels. Each one of these panels okay, so each one of these panels, the first panel, which is this one here, the main panel. The main panel is a 400 amp circuit breaker, and also it's a 240/120 volt single phase system. All of them are, and the second panel that's fit from it is I have 350, 175, 125. So this is 350, 175, 125. All of them are circuit breakers feeding each one of these panels. So now this is feeding 350 amp panel. This is 175 amp panel. This is 125 amp panel. These are the panels, the sub panels. Does that make sense? Everybody understand what you're looking at a well-line diagram? I brought a feeder of 400 amp, and I want to feed all these panels. So all of them are 24120 single phase dwelling. Please emphasize the word dwelling. It's an apartment building. That's exactly like your apartment. You're going to see why dwelling is very important in this case. Okay, so what do I need to do, Chad? Here's what I need to find. I need to find A, B, C, D, starting from top to bottom. I need to find A is here, A, B, C, and D. I need to find the A at the top, guys, is the service entrance conductor to the panel, and B, C, and D are the feeders. I need to find the feeders, size of the feeders, and the size of the service entrance conductors. Everybody knows that when you bring this is service panel. When you bring the conductor to the service panel, they're called by code service entrance conductors. These B, C, and D are called feeders. And if you guys read the sheet, I made it very clear that some of them are feeders, some are service entrance. Okay, minimum size entrance conductors. For hot and neutral, I'm going to pull full neutral. I'm not going to derate because we could derate. We're not going to get into that one. So let's do, this is very easy. Let's do A. Okay, for A, you take the 400 amp and take it to which table? 310.15 B. That residential table, special residential B7. That's the key one. B7. This is why we had this example. So if you guys go to 310.15 B7, not B16, B7, and for a 400 amp, and then by the way, if I don't tell you if it's copper or aluminum, you always default to where? Copper. And if I don't tell you I care about the neutral, if I don't remember, it's 240, look at it, it's 24120. So how many conductors do I need for this system? 3 conductors. And if I don't tell you I need you to size the neutral, you always pull what? Full neutral. They call it full neutral, same size basically. Did I ask about the neutral? No. So how many conductors? 3 conductors. Anybody knows why 3 conductors? 2 hots and a neutral, because I'm not asking you to derate the neutral. 3 conductors, what's the size?
400 kcm.
Thank you. It's a 400 kcm. That's it. See how easy that is? All right, let's go see. A, B. Let's go to B. Now B is 350 amp. We're going to go to the same table, table 310.15 B7. Why do I go to B for both service and feeders? The answer, if you guys read at the top of B, it tells you you can use this table for both service and feeders. Does it say branch circuits though? No, just service and feeders. Okay, is it the same size? No, 350 can give you 350. I'll give you the same thing, 3 conductors, 350 kcm. Now, what type of conductors? It could be THHW. Typically, if it's outside, it's going to be coming from underground. THHW has to have a W in it. Let's put the insulation as long as in it. THHW here. This is indoor, so it'll be THHN. The sizing wouldn't matter here. Okay, A, B, C, D. Let's do the D. See how that's easy now? D is what? 175 amp. Same table. 3 conductors. What's the size for 175? Thank you, sir. 1 aught. 1 aught. A, W, G, T, H, H, N. Okay? 1 aught. And last but not least, A, B, C, D. This is supposed to be a C, Chad. C, D. 125 amp. Same table. 3 conductors. What's the size?
2.
Size number 2. Number 2. A, W, G, T, H, H, and N. Can I have thumbs up, Chad? We know exactly how to use this table. The reason, Andrew, my friend, I put this on the task because that's exactly how you're going to size your apartment. When we get into sizing the apartment, almost, guys, the same sizes. You're going to see our apartment that we have, It's going to be close to 400 amp, and you're going to size it the same way. Yes, Aaron?
Just to verify, because we're putting everything in TH and defaulting it to TH and
Yeah, if you're, here's the default. The default, if you're indoor, THHN. If you're outdoor, THHW. Okay? Why? The key point is really wet and dry location. Can I have a thumbs up, Chad? We know exactly what you're doing. So, would you guys ace this tomorrow?
Nope.
No? Or B's it? C's
I
it?
can probably use it.
B's is good. As long as you don't D's it. Is D's it a word? Or F it is worse even.
You're recording the now on YouTube,
Oops.
so we'll
Now you're in. Okay, thank you guys.